If we brought one single teaspoon of this star to Earth, it would weigh When I was little and I would look up at the sky, I would see these familiar looking things that we call stars. And before I knew anything about stars, I actually thought that they were small and weighed like 2 grams. How can a star be that small if it's that far away? The sun is pretty big, pretty small, but pretty big. It's a star, so every other star out there must be absolutely gigantic. Well, not really. What if I told you that some stars are actually small? In fact, these stars are so incredibly special that they deserve their own name. Guess. It is called a small star. A neutron star. So what is a neutron star? Sure, it's small, but how is it so different from all the other stars in the first place? Well, before I even answer what a neutron star is, it's important for you to know that neutron stars didn't ever just pop out of existence. What I mean by that is, if there really was a Big Bang, evidence strongly suggests that there was, stars would start forming in later stages, but never neutron stars. They never came into existence from the Big Bang. Neutron stars always come from regular stars that have run out of fuel and collapsed. Or should I say, when a massive star runs out of fuel and collapses. It's not like the sun could become a neutron star, could it? Could it? Anyway, that should give you a pretty good idea of not only how a neutron star is different from any other star, but also what a neutron star is. It is the collapsed core of an absolutely massive star that was 10 to 25 solar masses. A solar mass is just the mass of one sun. What makes neutron stars surprisingly impressive is not how they have a mass 1.4 times that the sun, but they do so at a super small size. Let's talk density. Density is very simple but important to understand, and most importantly, visualize. Take 2 sugar cubes. They're the exact shape and size. Now replace one of those sugar cubes with a cube of iron. Notice that even when both of them are the exact same shape and size, the iron one is obviously heavier. Density is simply mass per unit of area. The heavier an object is within a certain area, the denser. That's why I'm saying it's absolutely mind-boggling when a neutron star packs the mass of the entire sun in a sphere that is just 20 kilometers across. And guess how big the sun is? 1.3927 million kilometers in diameter. If we brought one single teaspoon of neutron star to Earth, it would weigh 10 million tons. 1 teaspoon. 10 million tons. Something is funny around here though. Did you notice something strange about neutron stars? That maybe neutron stars seem to be strikingly similar to black holes. I mean, black holes are essentially dense and massive, and so are neutron stars. They both form in the first place because a star dies. So what on earth determines if a dying star will become a neutron star or a black hole? The easy answer would be that when really massive stars die, they collapse under their own extreme gravity and become a black hole. When stars are a bit less massive than this when dying, they explode and become neutron stars. But so does the same go for black holes. Going into more detail, when a neutron star is forming, the core gets compressed so hard to the point that electrons and protons start forming neutrons. Hence the exact reason they're called neutron stars. Negatively charged electrons combine with positively charged protons to form neutrally charged particles known as neutrons. Another important thing to mention is that neutron stars have a very strong but not infinitely strong gravitational pull. Black holes have an infinitely strong gravitational pull at the event horizon, such that even if you traveled at the speed of light, you wouldn't be able to escape the black hole. And according to Einstein's theory of special relativity, the speed of light is the speed limit of the universe. Despite this being, you would still have to travel 0.4 times the speed of light to escape the gravitational pull of a neutron star. The speed needed to escape the gravitational pull from a celestial object is known as the escape velocity. All in all, neutron stars are quite the impressive things in space. We didn't really talk about pulsars, but maybe for a future video. If there's anything we've learned, it's that stars don't exactly get as small as golf balls like I'd imagine when I was a kid, but that stars, although can't be as small as that, can be as small as cities. If you think science is cool and you want to learn things faster than the speed of light, then subscribe to start your journey. I make videos teaching others about astronomy and electricity. So if that sounds fun, subscribe to avoid being eaten by a black hole. Also, if you like the intro, I'll have the video for it right here. As always, keep on thinking.